Hello and welcome. Today we're going to be talking about Looker, a data platform and business intelligence tool, as well as Google BigQuery, specifically BigQuery Machine Learning or BQML, and how these two tools work together to create a seamless and efficient data science workflow. I'll be giving a crash course in Looker for those who aren't familiar with it, but specifically focusing on how this is tailored for the data scientist. As well as how BQML actually works, and of course, how they work together to create this workflow. So let's dive right into it. Here we are right now in Looker's development environment. Looker has its own language called LookML. This is just a SQL abstraction layer. So again, it allows for things like object encapsulation, reusability, repeatability, and version control. All of this is integrated with Git, while allowing the language of SQL to be used, which is very powerful, especially as we're trying to put together complex data sets. Instead of using tools like Python or R, which are imperative in nature, right? And you tell those tools how to create processes to get data sets. Here, we're using a declarative language like SQL. So much easier and simpler to do all of this data manipulation here. And we'll get into more why that's important down the line. But let's just quickly dive into how LookML really works. Effectively, we're just pointing at tables in our database and creating pointers to dimensions, which in this case are simple columns. But as we go down, you'll see we can do any of the functions that are available on that SQL database, in this case, Google BigQuery, and use things like inheritance effectively of objects to reference those other dimensions, allowing us to create these small encapsulated components of logic to build up and create very complex logic. So one of the big headaches that comes with SQL typically is the fact that to create a query, you need all of that logic living in one place. Very difficult to maintain if you want to make small changes to it or maintain that code over time. That's really where Looker comes in and helps. Now, diving in a little bit more complexity here, inside of Looker, we don't just have to point to specific tables in a database, but what we call derived tables. So these are fully custom SQL statements that we just wrap in this little SQL tag that Looker gives us. And Looker will handle in the background creating this table as needed for us so that we can use it and now define dimensions and measures off of this table. So again, allowing for even more complexity in using these kinds of derived tables, which you can really think about as views or even materialized views, as Looker does have the ability to write these back to the database, which I'll again talk a little bit more about in a minute. Once we've defined those, we can define what are called explorers. Explorers are essentially little apps that put this all together, right? How do these tables relate to each other? How should Looker generate SQL appropriately, not just on the dimensions component, but also the joins component, so that we can get queries that we actually care about. Additionally, we can define what are called data groups, and this will become important later, for basically a cadence that we're telling Looker to when to do any processes we care about, including materializing some of those tables in the database. And this is done with just a little trigger here. Essentially, on a cron job, Looker will run this small query here, and if ever the results are different than the last time it ran it, run this data group. So trigger all of those processes to go. So in this case, because I'm selecting the current date, Looker will run these processes every night at midnight because that's when that changes. So that's kind of the setup here. This is how we build out all that logic. What does this look like to the end user? Here is the explorer that we just created that was just defined over there in LookML. That's the markup language. And we have all those dimensions exposed out here. So again, all of those, regardless of how complex they are, those metrics are now just exposed out to us here, and we can start selecting them. So maybe I'm interested in that trip count, but specifically by the dates that those started. So I just kind of want to see this over time. I'm going to run this simple query here, and we're going to get all those results. I can visualize this. Maybe I want a scatter plot here, and we can quickly see that there's obviously some seasonality to this. And this is really the first part of that entire process of data exploration. I want to visually see how my data fits together. Of course, I can do more complex things around covariance and all of that, but this is a good starting point. Maybe the next thing that I'm interested in is not just seeing that date, but because I know that this is based seasonally, I want to bring in that weather data. As a side note here, all of this data, this is bike trips that happen to Seattle Bike Share. So this is publicly available data as well as the weather data. This all lives in BigQuery's public data sets. So I'm just going to use that. I've just pulled in this the temperature of those days, and I'm going to run this query itself. So now we can see by day, by temperature, the trip count. But for this purposes, because I just want to see how the temperature is correlated, I'm actually going to hide from the visualization the date so we can visualize this just as temperature and trip count, each point representing a specific day. Fantastic. And I can keep going with this exploration, see it by other variables, some of those derived variables, and keep going. And this is really that first part of the data science process, right? Getting an intuition for what the data looks like so that now I can start formulating what questions do I even care about? What do I want to answer? What do I want to predict? How do I want to go about all of this? So let's actually just stay with this exact query that we had where I want to use potentially temperature to predict how many trips will happen on that day. Now I could take the SQL that Looker has generated, which we can always check out right here, how it's building this out. But instead of that, I can use Looker's native derived table syntax, which I'm going to pull up over here. This is how in Looker we can define a derived table without actually writing out all the SQL. It knows to point to the appropriate SQL. In fact, as we change the definitions for those metrics, those will automatically update in these definitions, which is why I don't want to write just the raw SQL, because then I lose that inheritance model essentially. So this is much easier to do. In fact, I've already gone ahead and set this up. And here in the BQML, we can see exactly that table that I created. This is the only definition that I need for it. And this is going to be my input table. This is what I'm going to put into my model so that we can train off of it. So fantastic. We use Looker right now all the way up until this point to get the appropriate SQL statement that I want to feed into my model. And now is when BQML comes in, right? BigQuery not only has helped us put together these queries, but now will do the machine learning for us. And here I'm using, again, this derived table concept. And that's kind of the beauty of using SQL for machine learning. Everything is just tables and derived tables. We don't have to worry about different types of objects like a model object. No, that model itself is going to be a table. We're using Looker's new feature, SQL Create. This is different from SQL because instead of allowing Looker to handle how we're going to build these tables as select statements, we're going to explicitly tell BigQuery what we want this table to look like. So we actually put in that create statement at the top. But let's look at this from bottom up. From the bottom is our input. Select star, accept start date, which I'll get to in a second here, from that table. So again, the moment I make any changes to this table above, this will automatically cascade through because I'm just selecting star from there. Again, I've not included that start date. That's just there to get us to the right level of granularity, but I don't actually want to use that date to predict here. So you can imagine that there are dozens of columns here. Each one of those columns is complex derived dimensions or measures. As that changes, I don't need to change a single thing here. It just cascades right through. Again, that encapsulation and reusability paradigm here makes this a very seamless workflow. Once I have that, now I just put in the parameters of my model itself. In this case, it's linear regression. Right now, BigQuery also has the option of logistic regression with probably more options to come. And I also put in my dependent variable here under label. Everything else is going to be treated as an independent variable, right? We're going to use those as inputs to this and have this be the target variable that I'm trying to predict, as well as other variables that are, or parameters rather, to this model that our data scientists will be familiar with, and there's a whole slew of them. I only have a couple here included for the purpose of example. Now, I can also retrain this on that data group that I said before. So it's already built into Looker how often I want to retrain this model. I can set up that data group as I had done before, running at midnight or whatever it is that I want to set up for it, and we'll have that working right in here. Okay, now if I want to evaluate this model, BigQuery has given us some cool simple functions to be able to do that. So the first one here being, of course, the evaluate function, where I can input into it both the model that I just trained above, which again, I just reference that as a table. And Looker also takes care of the naming of these tables. There's some reasons why the names aren't so simple. It's part of the version control that Looker allows for, but effectively I can still just reference them as if they just had simple names, as well as my input data. Again, in this case, I'm evaluating on the same input data that I used to train it. You can put in another table as long as those column names are matching up. It doesn't matter. And in this case, to evaluate appropriately, I also need that dependent variable to be part of it. And then BigQuery spits out all of these dimensions, which of course Looker can immediately take advantage of. We also have model training information, this training info, where we only put in the model, nothing to do with any other table that we need to use this. It just tells us all the information about the loss, how long it took to do this, how many iterations, etc. So we get those dimensions exposed out again through Looker. So hop, skip, and a jump ahead, we can put all of that into a dashboard. All of those tables can be explored and put together into visualizations, so we have that information here for us. So in this case, we see we have a pretty bad R squared, which makes sense. We only have one variable predicting. And again, this is just the beginning of it. Again, R squared is a number between 0 and 1. You generally want to get it as close to 1 as possible. We also have some summary information about the errors here, as well as the model information itself. How many iterations did it take, etc., to build this model out. We'll see that the training loss here goes down. You want it to get lower and kind of zero in on a good model. We have some summary information about how long it took to train, etc. But now let's say I want to go back and actually make changes to this model. Well, that becomes really simple. Everything important about this model lives within this frame right here. Right? All of my inputs and the dependent variable are here, and all the model parameters are right there. Really quick and concise. So let's say I want to add another column here. In this case, let's say humidity. I know that's another important one. So I'm just going to put that in here. I already know how to reference that, really easy. But again, I could go back and build out more complex dimensions and measures if I think those are what are valuable. Again, through that exploration, whatever I've discovered, all of this iterative process stays within Looker, very simple to keep iterating upon. And now that I have this change, I don't need to change anything here on this select statement. I already am just selecting everything that I want from that prior table. This will cascade right through. But maybe I want to make some changes to the model parameters. Again, I can just do that right here. I don't have to leave. I don't have to pop this data out and go into another tool. I can use this all here. Once I have this all set up, I can come to my dashboard that I was just looking at and simply clear the cache and refresh this dashboard itself. Fantastic. I just fast forwarded a little bit there so that we could see what this looks like at the end. As you can see, my R squared went up. We're getting a little bit better of a model. It took a few more iterations and a little bit more time to do that. And we can again see how that training loss worked out over those iterations. So again, we can keep doing this and keep producing better and better models. And I've just stayed within this paradigm here where these are the only places where I need to make changes to my model. This is, again, very valuable because I don't need to worry about how exactly the data lives on the database in the sense of if I was writing Java code to work on this in cluster, nor do I have to worry about what subset of data I'm going to pull to work in Python or R on my laptop itself. Right? All of that is taken care of for me. I'm getting all the benefit of doing this in cluster, so all the performance benefits of that, as well as the simplicity of creating my metrics in this BQML way and feeding them into a model. Nice and simple and really seamless. Let's say I'm now confident with a model, again, hop, skip, and jump ahead here to a time when I'm ready to actually use this for prime time and do predictions. BigQuery has given us this nice simple predict function where again, the inputs to it are that regression, that model that we already have, as well as some new data set. Again, in this case, this should be a data set that is unlabeled. It won't have the actual trip count, but it has all of the dependent variables in it, and BigQuery will spit out for us a predicted trip count. I can create other dimensions and measures off of this, but most importantly, once I have this, what we see a lot of times in data science workflows is that just becomes a science project. Only other data scientists are looking at it because all of this lives in their notebook, and they have to create whole custom applications to get this actually exposed out. Whereas with Looker, that's as simple as creating an additional join in that model. Again, now this information is exposed out to all those other users. We already have everything in place with Looker, things like permissioning and access controls to the data, the visualization and content creation UI already exists there. The data scientist just needs to expose this data out in a simple way like this, and it's ready for everyone to use. I'm actually going to fast forward even further and assume that we have actually a more complex model that we've put together, both from the BQML side, but also in machine learning, where we're not only looking at predicting the trip count of all of Seattle, but station by station. As you know, these bike shares don't just have a central hub where people rent from, but all over the city are these stations. We've put together some forecasting for how many bikes are going to go to and leave each station based on weather, based on humidity, etc. I've put together a little Explorer for that. And again, fast forwarding to when I can create content around that, here's an example of actually operationalizing that data, where I have now for each station a prediction for the future based on forecasted weather. So I know what the weather is going to be tomorrow, and the temperature and humidity roughly, and I can use my model on historical weather data predicting how many bikes are going to be used from each station and put together a dashboard like this. So I have a predicted surplus or deficit for tomorrow on each station. And I can see that in this nice little summary. Moreover, Looker has integrations with other tools via webhooks, so essentially any other tool that is online effectively. And now I can send information from Looker there. So maybe I'm the manager of this bike share system, and I want to make sure that we are taking into account these deficits and surpluses. So here we have a negative surplus or a deficit on this particular station. I might want to reroute some bikes to it. And I just say where they're going from, where they're going to, how many bikes, and that can trigger a system or send a message to somebody that is in charge of these reroutings. So again, we went from having that just the raw data in BigQuery to being able to create models, exposing this out, and actually take action all within Looker. Once I've established a connection to BigQuery, I can do all of this work in one place, something that would require either an incredible amount of custom coding in a tool like Python, or a hodgepodge of various applications to be able to move seamlessly from predictions, data manipulation, and operationalization. Now we can do all of that effectively inside of Looker and have it working in real-world situations. Thank you for watching. Cheers.